was pretty clear to me then, almost 10 years after the discovery of the gene, that we really had no cures. And what was working for our patients was exercise and nutrition, which I had some practical experience with, but also I had trained in those areas. And we started applying that to our patients that had genetic disorders that either affected muscle and made the muscles weaker. And so the antithesis of muscle atrophy and weakness is hypertrophy that you get with exercise training. And then the big area I was involved in, which was a serendipitous discovery of a patient that had a primary mitochondrial disease within my first few weeks of starting my career.
What if the narrative of aging, one of inevitable decline, is fundamentally flawed? For decades, medicine has treated aging as a condition to be managed, not a process to be reshaped. But our guest today, Dr. Mark Tarnopolsky, offers a glimpse into a future worth building, where the relentless march of time is not a sentence, but a dialogue. A renowned physician scientist at the nexus of genetics, metabolism, and human performance, Dr. Tarnopolsky's work reveals that keys to vitality are not just hidden in complex gene therapies, but are accessible through the power of exercise and nutrition. He stands as a visionary architect of a new paradigm, one where we don't just extend lifespan, but reclaim our health span. Prepare to explore how we can rewrite our biological destiny one cell at a time. Dr. Mark Tarnopolsky is a renowned physician scientist whose work sits at the powerful nexus of genetics, exercise physiology, and aging. A trailblazer in neurometabolic and neuromuscular disorders, he leads pioneering research at McMaster University into how lifestyle interventions, particularly exercise and nutraceuticals, can mitigate genetic disease. More than 500 peer-reviewed publications, an H index of 140 plus. His impact spans academic, clinical, and entrepreneurial domains. And as the CEO of Exerkine Corporation and Stay Above Nutrition, Dr.
Tarnopolsky
translates research into real-world therapies. His journey from elite endurance athlete to innovator in longevity therapeutics reveals a life lived in pursuit of vitality, resilience, and transformation. And his story perfectly embodies the mission of DNA of Things, that is to illuminate how biology, innovation, and narrative combine to shape and reshape what it means to live well. Dr. Mark Tarnopolsky, welcome to the DNA of Things.
Thanks very much. Appreciate being here, and thanks for the invitation.
Oh, well, your reputation precedes you. We have common friends. Actually, Fadi was the one who introduced us, I think it was a long while back, six or so months ago. And then we were speaking to Kara recently, and she was singing your praises. And how long have you been at McMaster University?
I've been here a long time. I came here as an undergrad in 1979, if you can believe it, after my high school years, and left for a brief period of time to do some of my residency training in Rochester, New York, and worked part-time in Thunder Bay when my wife was doing her residency up there, and commuted back and forth. But for the most part, I've been here since 79.
Wow. And when were you officially a faculty at McMaster?
In 1996, I started here as a faculty member.
Okay. So you would have been there when I was visiting and applying. So that's actually you started there the year I was born. And I checked out McMaster University among other places in Toronto, but I ended up accepting my undergrad offer from Dalhousie University, and I actually did my PhD there as well. But I was captured by McMaster, and so here we go. The road has led me back here, and with good motivation and enthusiasm, that's for sure. Because you touch into an area that I'm quite passionate about. Obviously the application of healthy living in a clinical practice is, I want to say, seemingly axiomatic, obviously, yet not easy. Simple, but not easy. And you didn't get there by cliche or chicken soup. You've done a lot of work here to actually prove out the methodology. So really interested to understand how you got into this space, because you really started with the mitochondrial medicine. So how does that kind of evolve, and particularly, I mean, how you've synergized these seemingly disparate passions into a single career? So how did it all begin?
Yeah, I guess it really began in high school when I had a really insightful physiology professor who inspired me to go into human physiology. So I came to Mac in '79 with the goal to be like him. I wanted to be a physical education teacher. So I did a combination of biology and physical education for 4 years. And as I was going through, another inspiring person, Duncan McDougall, who unfortunately passed away recently, who's one of Canada's sort of pioneering physiologists, was my mentor for my 4th year project. And, I started off, if you can believe it, many years ago doing football and downhill skiing, and lost 35 pounds when I started running and realized that I was more of an endurance athlete. So that's kind of always been there in the background, my interest in sports. And that really matured in my undergrad, where I discovered endurance sports and realized that that's kind of where my physiology was, and went to the World Championships for ski orienteering. And we were one of the top teams in Ontario in cross-country skiing. And so I wanted to continue to study how exercise could impact human physiology. I went off after that, did medicine. I was hoping then to be a sports medicine doctor. Then got really interested in the research and came back and did a PhD, partially with Dr. McDougall and Dr. Stephanie Atkinson, who's in the nutrition department, where I got interest in nutrition. Then after that, I said, well, to practice, I really need a residency. So I trained in internal medicine, neurology, and something called physical medicine rehabilitation, and also spent 3 years at night doing extra work in intensive care. So when I finished, I said, geez, what am I going to do with my life in terms of my career? So at the time, my goal was to study and to look after patients who had nerve and muscle disorder. And it was pretty clear at the time that there really were no effective therapies. Everyone was hand waving when they discovered the gene for Duchenne dystrophy. They'd have a cure in 5 years. But it was pretty clear to me then, almost 10 years after the discovery of the gene, that we really had no cures. And what was working for our patients was exercise and nutrition, which I had some practical experience with, but also I had trained in those areas. And we started applying that to our patients that had genetic disorders that either affected muscle and made the muscles weaker. And so sort of the antithesis of muscle atrophy and weakness is hypertrophy that you get with exercise training. And then the big area I was involved in, which was sort of a serendipitous discovery of a patient that had a primary mitochondrial disease within my first few weeks of starting my career. And so mitochondrial dysfunction, these genetic disorders, people have such dramatic impairment that even getting up to get a glass of water is pretty much your VO2 max. And then on the opposite of that is, what I was involved in, which was endurance exercise, where we have mitochondrial biogenesis and very high VO2 max. So what I learned in physiology about how we can take a sedentary person and, do weight training and get big muscles and stronger, take a sedentary person and do endurance training and increase mitochondria and improve VO2 max, we started to apply that to our patients. And it was pretty clear that, sort of the theme in neurology is therapeutic nihilism. We can diagnose, but we can't treat anyone. And, through my whole career, I've been trying to pay attention to details of your habitual diet. Are there any supplements that can further enhance the benefits? How can we manipulate these in combination with exercise to either increase strength in those with weakness, like muscular dystrophy, or improve metabolic efficiency if you've got, McArdle's disease where you can't oxidize carbohydrates, various fat oxidation defects where you can't use fats, or mitochondrial disease where whatever substrate you give, it just can't be utilized. And we and others have clearly shown that really the most effective therapy for most of these disorders, as is the case with aging, turns out to be exercise and nutrition done properly and studied very carefully to make sure that we get the optimal combination with fewer to no side effects, or at least mitigate those side effects.
Mm-hmm. What about any autoimmune stuff? Have you done any work there or come across it? Like, for example, multiple sclerosis?
Yeah, so autoimmune disorders that I would be most involved with are the autoimmune muscle disorders. I'm also to some extent involved in the nerve disorders like Guillain-Barré syndrome when kids come in with Guillain-Barré, which affects the nerves. But most of what we would see would be as dermatomyositis, polymyositis, and we don't know if it's truly an inflammatory disorder, but there is secondary inflammation in something called inclusion body myopathy. which is a sporadic disorder more common in men than women, but it is definitely an age-associated disorder causing inflammation, mitochondrial dysfunction, all the stuff that we all are experiencing as we age, those 5 common pathways of inflammation, oxidative stress, mitochondrial dysfunction, impaired protein synthesis. All of those are involved to a large extent in the disorders that we see as they are in aging. And it just depends on, what's the main issue. Do you have a genetic disorder that affects mitochondria? Then you get the secondary effects. Do you have a genetic disorder like a certain form of ALS that affects oxidative stress? Then you get secondary mitochondrial dysfunction. So,
Right.
at the end of the day, they all kind of converge in a similar fashion at the cellular level.
Yeah, interesting to hear you speak really about the two extremes of the population. Let's say, I mean, it's death with like rare disease and well, it's physical transcendence in a way with
Right.
athletic performance and when you're operating at the tip of the spear, and the outcome is very clear. It's world record or life. I think it makes for effective measurement, right? Like, so I think about, for example, how we know a lot of how we know much of what we know about nutrition, for example, with respect to RDAs, comes from, well, men going off to war and being without nutrition and, being given survival nutrition with, let's just say lower nutritional density. And so, in the space that you work, it's, well, see, I would call those, and this isn't the right language, but just forgive me. It's like, if you had designed an experiment that way, let's say it would be an unethical experiment, right? Let's send these guys out with suboptimal food and see what happens in the most stressful conditions, for example. But, then it would be irresponsible not to do the perspectival research, certainly. And that was something that I started to see in, the work that we had done when we worked with athletes previously, predominantly, track and field athletes, is they're subjecting themselves to very dangerous things. It's like, run as fast as you can, jump as high as you can, right? Jump as far as you can. And they're willing to throw caution to the wind. And, obviously they have great coaches, but then you measure success and you also interestingly measure, failure. One of the things that I saw working with these athletes who had survived long enough in, the high performance world, to be pre-Olympic or Olympic athletes, and which means they had to survive the training, which is not easy. And what was interesting is that we found 75% of them had injury protective alleles, which if you were to compare it to the general population, it would be more like 50 to 25%. So certainly there's something going on there in terms of the athlete just being able to survive varsity training. And then, on the flip side, I've been doing, some work with the rare disease community. And what's interesting there is on rare disease, I mean, it's a bit of a misnomer, actually, because if you were to put all rare disease into one bucket, it's like, well, there's 300 million diagnosed. Okay, well, what about the undiagnosed? Probably close to 1 billion. And then if you were to throw the carriers into that, it's like probably everybody.
Right.
So what I'm interested in, what I'm getting at there, insofar as the rare disease and how it relates to performance, if I'm thinking about this biologically or evolutionarily speaking, similarly like an athlete, it's like you get through certain phases of life and development, but then these mutations pop up and, the pathology is showing patterns. And the treatments are, as it relates to nutrition and exercise, there seems to be some kind of blanket positive impact. But when you think about, technology, where it was when you started and where we are now, do you see a way, to look at either end of those extremes and I guess understand these mutations better evolutionarily speaking, but then even get more precise and predictive with the clinical application? And it may be a certain point where it's like, hey, we don't need to go that deep, but that would be an interesting thing to know too.
Yeah, I think, there's a number of ways to look at it. You can either go very reductionist and, really try to pick things apart, or you can take a broader approach to it. So, for example, from an athletic performance, people are trying to find, what gene predicts this or predicts that. But my grade 12 coach in track could look at me and say, yeah, no, you are not a sprinter, you are an endurance athlete. But of course, when you're a testosterone-filled teenager, you want to do football and downhill skiing, you don't want to do endurance sports. Right. So there's the flip side. I mean, you can either really get down to it, do muscle biopsies, which, my understanding is East Germany and Russia, we're trying to do biopsies on people and put them into specific camps based on your fiber type composition and stuff. But really, you can also take the, hand waving approach and just have your coach say, we think you're better at this versus that. And they're usually as good as I think anything that we could do. And so there's a lot of people thinking that we can now take a look at the gene and say this person has a SNP that predicts that they're going to do better. And those are roughly predictive. But at the end of the day, I think we're kind of missing the point. Number one, I think we're missing the scientific point, and it's not just your genes. We also have methylation. So you can have a set of genes and you can mess it up by eating poorly, mess up the methylation, downregulate or upregulate certain genes just by sticking, a methyl group on that DNA. We also have glycomics. So different glycosylation patterns can predict adaptation to exercise. You can even look at glycosylation and methylation and look at somebody's age. You can look at different splicing adaptations. So there's so many levels that the complexity, I think, just becomes kind of extreme. So although I do study basic science and, we look at, monogenetic disorders, which predict disease, and, we find new mutations and we try to prove it at various different cellular techniques to show that there is that disorder. But when it comes to human aging, I think really there's some key points that are broad strokes, I think, for most people. And that is, eating properly, paying attention to, protein requirements and good quality protein throughout your lifespan. Exercising from a health perspective is very different than exercising for performance. So when I was younger, exercising for performance involved big base for aerobic capacity, putting in, 600, 800 hours of, base endurance training, coming up to the activity, very specific, 6-minute on, 3-minute off intervals, very terrain specific. If, the race is going to have a lot of hills, and really getting into the minutia. Whereas, as I started to get older, I think my research became much more clear. And that is that as we age, we need a combination of both endurance and resistance exercise. And so simple things like titrating in more resistance activity as we age for an endurance athlete is going to be healthier than just sticking to the endurance activity. And the flip side, just doing weights, you're ignoring the beneficial effects of aerobic activity. And so there's some really simple things, I think, that work across the spectrum for individuals, for a population to be very healthy. Now, when you get down to the, as you say, the sharp end of the stick for specific sports, your genes, to a large extent, give you a window of opportunity. So, for example, my window of opportunity was never to be a top sports sprinter. Sounds like you were a much better sprinter. Your gene profile puts you into that window. But then there's infinite aspects that go into it. Injury, availability. I mean, if you don't have a ski jump near your home, you're never going to be a world-class ski jumper, et cetera. You stick a dome for speed skating, and that's where your speed skaters come from. They don't come from Northern Ontario where there's no speed skating tracks. So there's so many things that go into it. But I like your point about injury. So when you think about the thousands and thousands of people that have incredible genetics, incredible VO2, even the opportunity for sports, but you twist your ankle on a rock, nobody can control that. And you start to accumulate various injuries. And to a large extent, I mean, you look at Jakob Ingebrigtsen right now, best 1500 meter runner in the world. My understanding is, I haven't seen him at races, that he's got a calf injury. So it doesn't matter how good you are, there can be this accumulated injury. And that's part of aging. All of us start to get some degree of osteoarthritis. For me, my big step decline was I ripped all my hamstrings off at 42. That capacity knocked down, my fitness and my performance capacity. And so that randomness of accumulated damage that we all get is part of aging, and something that I think for most of us, you can work through it, but you have to give up the fact that, at one point I was an elite athlete. That will always fall off for all of us. There's many examples of people who continue to think that they're still going to be elite when they're well past their prime, and just accept and embrace aging. And, there's many things we can do to have a long health span, and add about 4 years to our lifespan with proper exercise and nutrition.
I like, the injury thread is a good one. I remember the first kind of real injury that I had. It turned out I was combining martial arts with baseball, and I had hypermobility in my low spine. It turned out I also had a spondylolisthesis, right? So, I remember I was having the greatest game of my, I guess I would have been my 14 or 15-year-old career. And, I had double triples, and I was pitching that game, and they were playing me to pull, and I took it to the opposite field. And I started to run down the baseline. It was like, boom, back spasm, and I got thrown out from the outfield. Here's the guy who hit, stretched two hits that game for extra bases. And then I remember going and seeing the specialist after, and what he had said was something like, we said two things. It was like, Doc, it hurts when I do this. And he's like, well, don't do that. So it's like, okay. And then the other thing was, well, hey, if you're going to go and do sport, you're exposing yourself to, the possibility of injury. And so if that's what you're going to do, then you have to, go into that knowing that there's a higher risk. And then on the flip side, it's like, well, if you go to the other extreme, you do nothing. Well, here are the consequences of that. And so it was always kind of like, walking that line between, I want to go to the Olympics versus how many surgeries do I need to have before I stop trying to do that? Right. And then how do I, reorient on, as you say, I like it as like, performance longevity. Well, right. Okay, my goal isn't to break 10 seconds. My goal is to lift up my daughter and to play with her and teach her to dance and, teach her martial arts. And so, okay, what things do I need to do so I can do that for the next 20 years. Right. And so that's I would call that an upgrade, but, I do want to come into, how we can actually do that very personally and in a way that I think it makes it very motivational, because, sometimes it's, okay, maybe especially for the recovering athletes, let's say, it's hard to take the generic, obvious, axiomatic advice and do it because it's boring. And I think a lot of people, I think, what is it they say is to treat everybody differently is you treat everybody the same by treating them differently, so to speak. Right. And so like, if I know I have a diet plan for me, for not just my genes, but my goals and my injury history and my DNA, I don't know, there's something special about that. Does that make me more inclined to do it? I'm sure that's going to be population dependent. But before we, at the risk of going too granular, there's some, things that you were pioneering before it was cool. Like you mentioned protein. Like, I don't think that was cool or even accepted when you recommended it.
Yeah.
And how did that come into, hey, eat more protein? I'm studying mitochondrial disease, eat more protein. Like, how was that received?
Yeah, it was part of my earlier career. As I mentioned, I did my 4th year project with Dr. McDougall, and then my PhD working on this. So at the time, the US, Canadian, and UK government said that protein requirements for sedentary people were exactly the same as top sport athletes. Now, as a former top sport athlete, and I was a top sport athlete at the time, I thought that was garbage. I looked at what my buddies and I ate, and we ate so many calories that our protein intake was reasonably high. And so we wanted to study it. Now, at the time, the technology, which gets back to one of your earlier points, was to essentially go to the minimalist. So what's the lowest protein you can take to stay in nitrogen balance? And that's how people determine protein requirements. So you go to a very low level, and then when you cross a minimum floor, you actually start, burning more protein than you're actually taking in. And at that sort of threshold, that's what they call the protein requirements. So what we did is we looked at top sport runners who had a VO2 max of 75 mils per kilogram on average. And so some really top athletes. And we looked at sedentary folks. And we used the technology at the time called nitrogen balance, put them on different protein intakes to determine the median, then we added 2 standard deviations to cover the population. So 2 things came out of that. One, we suggested, which has now been proven by innumerable studies, that top sport endurance athletes need about twice the dietary protein intake versus sedentary individuals. A little less for females for complex reasons we eventually discovered. But nevertheless, even the women need probably 70% more than the Canadian RDA if you're a top sport athlete. And I was personally laughed out of meetings by the old British established nutritionist saying, well, when a British gentleman was taking a walk on the moor, their protein intake was not elevated. But again, that's not top sport athletes. So it's a complete lack of understanding of what it's like to train 7 days a week, to be doing 2 to 3 hour runs on the weekend, intervals, a whole different kettle of fish. And, some people said, well, who cares? It's a small fraction of the population. My point as a scientist is, well, I still think, we have nuanced nutrition. If you're a top sport athlete and you're told that you're okay on the Canadian RDI, you're not. And we've done a study, which I still have my postdoc to finally publish, where we tried to put even moderately trained athletes on the Canadian RDA for a week, and they couldn't even finish a week of exercise training. They were so pooched. So that was one of the first areas that I was involved in. We also showed that the bodybuilders that had been training for years and years didn't need as much protein as they thought they did. And that was a bit of heresy at the time. And I'm sure Joe Weider and others didn't like me because we were saying, hey, you don't need to be taking 3, 4, 5 grams of protein per kilo. You're fine on about 50 to 60% more than the Canadian DRI. So we really tried to, I think, nuance protein requirements for men, for women. And as folks got older, there were a number of groups, Bill Evans, my group, Stu Phillips, and others have clearly shown that as we age, we get something called anabolic resistance. And we also are seeing that in our patients because the muscular dystrophies, the inflammatory myopathies, et cetera, there's an impairment of our body's ability to take the amino acids from protein and to incorporate them into muscle protein. And so as a consequence, exercise is critical, timing of nutrition is critical. And from a protein perspective, the quality of the nutrition is something that's really important because, as you know, we've got the essential and the non-essential amino acids. We need a certain amount of leucine to help trigger protein synthesis, but then we need the other essential amino acids to come in. I'm a big fan of milk and Mother Nature. As humans, what do we feed our babies? Milk. And milk for a human is different than milk for a cow. So cows have mostly casein and smaller amounts of whey. We have more whey versus casein. And Stu Phillips, myself, and others have clearly shown that the whey protein comes in quickly, turns on protein synthesis. Casein comes in slowly and attenuates protein degradation. So your net accumulation is higher. So protein requirements can be nuanced to the quality of the protein. They can be nuanced to aging. And as we age, we need a little bit more. And as we stress the body with different types of exercise to optimize adaptation, we do need more protein. And that can be nuanced too with timing. Immediately post-exercise does tend to incorporate a little more effectively the amino acids that we're taking in from protein. So that was really the first area that I was involved in from a nutritional perspective. And now we're looking at obesity, aging, muscle disease, and showing that under all of these circumstances, it's even more important to be very, very nuanced and careful about the quality, the timing, and the quantity of protein that one's taking in.
Yeah. As you're speaking, and you've probably experienced this as well, I think back to my athletic career and the role of nutrition. I mean, it cannot be understated. But after I stopped competing, I was on the other side of my track and field career and, was just so fortunate to be exposed to all these disciplines like, martial arts. It was like Taekwondo and boxing and, baseball, great hand-eye coordination. And, but then as the sprinter, as we talked about before, and swimming, and I never, like the exposure to all those different disciplines gave me this wonderful physical versatility. The hypertrophy and the strength building obviously was cross training for all these sports, or I don't know if cross training would be the right word, because it was so mandatory in sprinting, let's say. But, when I was on the other side of competition and I mentioned I was kind of carrying all these injuries, I went, as let's call it a regeneration recovery strategy. I did one of these like fitness competitions. I wouldn't call it bodybuilding. I wasn't interested in that kind of output. I was interested in symmetry and rebalancing kind of post-surgical. And I was like, I'm one of those people who really loves to have a goal. And so I said, okay, I'll do the men's physique. And, I dialed in my nutrition more there than I ever had, because like you could literally see the difference. And once you start to, and I'm not recommending this, once you start to play with the different macro nutrient ratios, like in particular, there's a phase when you go kind of pre-competition, pre-stage readiness, which is not dissimilar from, say racing in the endurance sport. There's essentially a carbohydrate depletion phase, and then a reintroduction, and also with hydration and salts. And I was amazed to see like the body transformation in days, and that it didn't stop. Like, and then you're done competing. So I was like, oh, I'm going to keep eating. And that was a mistake. As much as I had like a nutrition strategy, like loading strategy, there really ought to have been an unloading strategy, because it felt like I could just keep eating and eating, and everything was being shunted into my muscles. And I was like, oh, I think this is how the beef cattle industry works. When they talk about, grass-fed, grain-finished, and it just gives you a sense of just how amazing, the body is, and just how quickly it can change, but then how much of that is permanent versus impermanent. In this case, it was really, muscle glycogen felt like it doubled or tripled in the span of days. Like literally I gained 20 pounds in one day, if you can imagine that, just from hydration. Maybe not one day, maybe 2 or 3 days. I'm exaggerating. That's that whole older you get, better than you were kind of thing. But so I wanted to give carbohydrates their due, and also, fats as well, where you start to hear a lot about, suboptimal nutrition and trans fats and depleted micronutrients. And just given that we didn't even actually talk about, and I wanted to make sure we carve a good amount of time, talk about your entrepreneurial pursuits, because here you are, you've got the the MD background, you've got the PhD background, but you're also quite entrepreneurial in the nutritional space and making your solutions widely available. And so, interested to learn more about, how you've taken these research insights, basic research insights, but made them practical and accessible as an entrepreneur.
Yeah. So one of the things that has always bothered me is false health claims. And it is absolutely shocking now. And I see it even more, where people are saying something is clinically proven and there's no clinical trial. So what happened about 10 years ago is decided to start a company, and it was called Exerkine. So I was the first to coin this term Exerkine, which are the proteins in the microRNA which go up in response to exercise. So it's a twist on a concept that Bento Peterson and Mark Fabreo came up with about 5 years before I coined the Exerkine term. They called it a myokine. So they identified interleukin-6 as a myokine that came from muscle, which then turned on gluconeogenesis in the liver. And we now know it has anti-cancer effects and other things when it pulses with exercise. So the hypothesis was there are probably proteins in microRNA that go up when we exercise, which confer some of the multisystemic benefits. So long-term endurance exercise gives you 4 years of lifespan extension, about 10 years of health span extension, lowers the risk of cataracts, cardiovascular disease, dementia. So these multisystemic benefits must be something that's circulating. And so, I said, I don't know if it's coming from the liver, from muscle, from fat. So why don't we just call them exerkines, anything that goes up in response to exercise? So we set out to try and profile these exerkines. We took blood from sedentary people, top sport athletes before and after exercise, put them on a petri dish to see when they turned on mitochondria. We found that it was more the athletes, which again is an adaptive response, immediately post-exercise when we applied the serum that turned on mitochondria. So then we, did proteomics to try and figure out what the proteins were. And we identified interleukin-15 as one of the main things. I won't go through the science behind it, but eventually we gave that back in little pulses to mice, and it worked. It increased their muscle mass. It improved the mitochondria in their muscle and in their skin. So based on that, we said, well, why don't we just identify all sorts of exerkines, put them in a pen, and then we can perhaps give back to our patients who have severe disease where they can't exercise. I hate to use the term, exercise in a pen. It's sort of like your Ozempic exercise injection. So that was the concept. We got involved in something called an exosome, and we were trying to because we know that exosomes carry some of these proteins and microRNAs. So we were trying to use that as a gene therapy delivery mechanism. We had a patient with mitochondrial disease for complex reasons, proved that it could never work. We went bankrupt, and then we restarted again with more of the nutritional aspect. As you've heard, I've had this interest in nutrition, back in the 80s, and know quite a bit about it. I've been following, obviously nutrition and doing work on it for a long time. So Stu Phillips, my first postdoc, Johnny Parisi, my first grad student, came up with a combination which we now call Muscle 5, and that's whey protein, creatine monohydrate. We published about 30 papers on that, vitamin D, calcium, and omega-3 fish oil. So they did a randomized trial in older adults where they did weight training, which is obviously very good for people. We and others have shown you increase strength, functional capacity, and muscle mass in older adults when you weight train. But it was enhanced when they took this Muscle 5 versus collagen. So my wife and I took some of our money. We essentially bought the patent off of them. We reformulated it with and I've already mentioned my evolutionary interest. And I said, well, why don't we not use whey protein? Let's use this humanized milk ratio of 60% whey, 40% casein, so we can really optimize protein synthesis. We dropped the protein amount from 60 grams to 40 to make it, more attractive for women and for most people to take a slightly smaller amount. We replicated their study with a great postdoc that I had years ago, Dr. Mats Nilsson, and showed essentially that when we took this Muscle 5 versus collagen, we had better increase in muscle strength. We had better increase in function, like going upstairs, getting up and walking 10 meters and sitting down. And when we looked at the obese and overweight people, i.e. those who could be taking Ozempic, who would be eligible for it, we found that there was almost no benefit whatsoever to the collagen. They actually got more obese. They didn't increase their muscle mass at all in spite of 3 months of weight training, and yet they increased muscle, decreased body fat, and improved performance. So with that, we then marketed this Muscle 5. Another clinical trial with an independent group used just that alone without the omega-3s in young people to show enhancement of muscle gains with weight training. And recently, it hasn't been published yet, but another independent third party combined two things, which I'll talk about, the Muscle 5 and the Trim 7, in overweight men and women who'd be eligible for Ozempic, gave them the advice that you should when you take these GLP-1 drugs for weight loss, and that is exercise, control your nutrition, and do 150 to 180 minutes of exercise per week. Those who took, again, the Muscle 5 and this Trim 7, which is a mitochondrial enhancer, gained more muscle. Women in particular, even more so than the men, lost quite a bit of body fat. So it's really one of the only strategies that I've ever read about where you can lose fat but gain muscle. So if you take GLP-1/Ozempic, which most people have heard of, you will lose bone and muscle. If you do bariatric surgery, you'll lose bone and muscle. Or if you just do a low-calorie diet, you'll lose bone and muscle. So the only way that we found, in spite of doing exercise with those other strategies, you still continue to lose, was with our combination. So those are two of the main products. We have a variety of other things, but I think the main thing that I want to get across is that we've done a very different approach, which was to some extent not a smart approach from an entrepreneurial perspective. And that is, we tried to do a pharma nutraceutical approach. And what I mean by that is we have preclinical work. We do safety studies from preclinical. We then do randomized double-blind studies with good clinical practice guidelines. We have independent third parties blind the stuff for us. So all of the things that give credibility and avoid, quote, cooking the books, we apply. Problem there is you spend many millions of dollars to do these clinical trials. And I've only mentioned just a few of the ones we've done. And you can have some kid come out of grade 12, make some false claims, say that it's clinically backed, borrow someone else's science, and, have a good TikTok influencer, and they can make 50 to 100 times more than we do. But ultimately, I do think that it's going to resonate with the population that's becoming more and more aware of what's real and what's not, but also with, some of the bigger players, the Nestle's of the world, the, Abbott's of the world. These are folks who, will not be looking at products that aren't built and backed by science. And because of that, we have patents on everything that we've done, which costs a huge amount of money. And we've got true real world clinical data in the populations that we're studying. And, probably the most exciting thing that we've done is the product behind me, the TRIM7, which, if we have time, I can talk about it, because that was based on our mitochondrial enhancement. So to treat mitochondrial patients, I put forward a hypothesis in 2001, where treating neurologic disorders, we have to target these final common pathways, which, interestingly enough, are now well accepted as the final common pathways of aging, which is the mitochondrial disease we all have. And that is oxidative stress, mitochondrial dysfunction, inflammation, apoptosis, impaired proteolysis, decreased protein synthesis, et cetera. So what we did is 2007, we gave to our patients with genetic mitochondrial disease coenzyme Q10, alpha lipoic acid, vitamin E, and creatine. And we showed that we could lower oxidative stress in these patients where it was very elevated, and we improved mitochondrial function. We then said, well, what about more common disorders? So obesity and type 2 diabetes. Again, these final common pathways are there in fat and in liver, for example, in fatty liver disease. So we did many preclinical studies with a whole bunch of different combinations of mitochondrial enhancers, antioxidants, and came up with the essential 7. And then we did a randomized trial in younger men and women who were eligible for Ozempic, the overweight and obese category, and gave them the typical guidelines for exercise and nutrition. And at the end of it, we found that the folks who lost weight on TRIM7 lost only fat, but not muscle. And again, so that's by targeting the mitochondria. And in our preclinical work, it's pretty clear that what we're doing is activating mitochondria in the white adipose tissue, and that's called browning of adipose tissue. So we're turning your fat stores from a storage site into a furnace, for lack of a better term. And we also, with my colleague Greg Steinberg, looked at fat oxidation was enhanced, metabolic rate was enhanced when they took this product in our preclinical work. So I mean, that's what we've been doing.
Yeah, and that's pretty amazing. That the what did you call it when you're basically the brown fat synthesis? Was a term for that?
So browning of adipose tissue.
Browning of adipose, yeah. I mean, that's what happens when women become pregnant, isn't it? To some effect.
So browning of adipose tissue, it was first described in bumblebees. They have these inefficient cycles, and bears, they've got a lot of this brown adipose tissue. Humans have it, especially younger children, between your scapula and your neck region. And they have lots of mitochondria. Now, you can't do much about our brown fat as humans, but most of us have tons. Even as an athlete, I've got tons of white adipose tissue everywhere. So by increasing the mitochondrial capacity a little bit in the white adipose tissue, we've got this huge metabolic furnace that we can take advantage of. And that's beiging or browning of adipose tissue, i.e. we just increase the mitochondria. And we've shown that in multiple preclinical studies. In addition, we've shown in both preclinical studies by an independent third party, very significant improvement in fatty liver disease, for which there's pretty much no treatment. We also showed that the main markers of fatty liver disease were favorably enhanced in our clinical trial of the overweight men and women who were overweight or obese.
Amazing. And you kind of you took somewhere that I wanted to go in terms of questioning around what a lot of the popular, maybe non-scientifically backed recommendations are today. I'll hear a lot of the clients that I consult with who, their goal is longevity. So their age is 50 plus on their way to 70. Like, oh, should I take creatine or should I take branched chain amino acids? And there's kind of these single, in pursuit of a single silver bullet type of solution. Right. And of course, I mean, it's not so simple. And I remember actually being just fascinated by meat factor protein. It's like, what is it that helps iron absorption? Meat factor protein. Well, what's that? It's like, well, we don't exactly know. It's some combination of proteins that it's available in meat. And, when you take iron on your own, the absorption isn't as good. So there's this meat factor protein, right? So to me, it's like speaking to synergistically what's going on to get the outcome, which again, it speaks to even what we saw with the athletes, right? Okay, well, you may be genetically predisposed to this, but what's your environment like? What are your behaviors like? Because I mean, there could be behaviors that counteract, everything that you're trying to do, which I think that's what makes these double-blind clinical studies in nutrition in particular very, very hard to control for. So, I mean, kudos to you for being able to do that and to collect and to get patent on, the outcomes, so that you don't just get patents, right? I mean, there has to be something patentable. So, yeah. Interested to, I wonder so you think about the populations that you work with. And so what I'm thinking about now is, this is big in the pharma industry now. Like, I mean, everybody's hearing about what's going on with 23andMe and Regeneron purchase, and actually Anne's trying to recapture it. I think we're going to find out. Actually, if we didn't already find out, I think that was yesterday or any day now. But yeah, like pharma is looking at genetics to, help with, say, drug targeting, right? So looking at genetic differences. But now there's also, there's a future that we're going to see where everybody's DNA is sequenced from birth, right? I mean, how long it takes for that to become useful is another conversation.
Yeah.
But like I said, I've been thinking about DNA for 25 years. So I think I know some of the right questions to ask as it relates to my daughter's health. So I have an unfair advantage in that way. It's not ready for prime time clinically, although I will bring it into conversations with the pediatrician and actually add, a layer of perspective that has led to very, constructive conversation. But the point that I'm going at with this, though, is even just like, say, again, we're talking about the pharmaceutical industry, okay, for drug discovery, drug design, potentially. But then there's even, as we know, differential response to different pharmaceuticals. Like, we're learning more from, polygenic risk scores, for example, that you may do well to be on a statin sooner, whereas, others, genetically speaking, are not going to have the desired outcome from the drug. So they may require a different strategy. So as it relates to, well, this is big in Canada right now too, right? I think it was Genome Canada that announced some, I can't remember what the number was, but close to, 200 million in sequencing the population, understanding the diversity of the population. Do you see that access to omics data as something that is going to help or hinder the research that you're doing?
Well, there's many examples where I think that there are pharmaconutrigenomic interactions.
Yes.
I've got two good examples. So one that's very common, that's macular degeneration, which is a disorder that 30% of us will experience. It's an age-associated disorder. You start to lose your central vision. Again, all of the things, impaired autophagy, mitochondrial dysfunction, oxidative stress. And we are working on a strategy for that, again, with the multi-ingredient supplement approach. But the common medication came from a study called the ARED study, and it's marketed as something called Vitalux. So the AREDS formula, on average, did slow the progression of macular degeneration in sort of the intermediate form. However, what became apparent is that there were two polymorphisms that were discovered where people actually got worse. So, on hand waving, you go and you pick it up, go to Costco, you don't know if you've got the polymorphism or not. So 15% of the population, because of the high zinc content in the formulation, they were actually getting worse with the formulation, not better. And so when that became apparent, a lot of some of the companies dropped the zinc from 80 to 25 milligrams, which was prudent because I think 80 is a little bit high. But some of the ophthalmologists stopped prescribing it, and because they didn't have accessibility for this to find these polymorphisms. And the same is true of a disease we treat. So for mitochondrial disorders, there was a synthetic form of coenzyme Q10 that was formed called idabenone. And again, about the same proportion actually do worse on idabenone from a different polymorphism. And we've looked at that, certainly in vitro, and we've clearly shown that our mitochore, which is the alpha-lipoic acid CoQ10, the vitamin E, and depending on the study, we often add creatine as well, works across those variants. So whether you have those variants or not, they work. And I think part of why these work is, number one, it's a mixture of what we have in our body already. So everyone has these. We're just putting them into logical proportions, that mimic, what we're targeting based on, lower doses versus high megadoses of single agents to get an effect. For example, we did a study in 2007 with that mitochore people criticized me as they always do and said, we don't know which one's working. So I said, okay, fine, we'll do just CoQ10 because everyone thought that's what was working. So we used very high doses of coenzyme Q10 in a 30-person randomized double-blind crossover study published in 2010. MR spectroscopy, genetically confirmed patients, data blinding, GCP, the whole bit, showed absolutely nothing whatsoever. So again, hand waving about a supplement doing X, Y, and Z without clinical trial data is hand waving. And if people don't learn anything from this podcast, number one, make sure whatever you put into your body, if someone makes a claim about a supplement, go in, and if you can't find a randomized clinical trial, don't believe it. And you see that with so many products out there. There's just no data whatsoever for them. So people have to be very careful. And I think, if we had some genomic data, I think we're going to understand, where certain things, like I've given the example of the AREDS formula or Vitalux and idavenone, where it can actually do more harm than good. And yet most people think, it's got a bunch of antioxidants in it. This Vitalux is going to be great for me. How could it possibly do harm? But again, I think better knowledge of our genomic profile is going to help us from that perspective. Again, I don't want to see genetics used in the wrong way. And that is, if someone told me that my genetic makeup was to, go running on pavement, I would say, well, screw you. I don't care because I hate running on pavement. So I think, there can be good and harm from it. I think if people then start to avoid things that they might like, a certain type of exercise, because you're not genetically predisposed to it, that can do harm. And certainly from an exercise perspective, I think any exercise is good. Do give kids a smorgasbord of activities, let them pick what they like, and then people are going to do it for, throughout their whole life. And we also have to change society to make certain things more acceptable. I mean, only recently do we have bike lanes. I mean, I've been hit by a car twice in Hamilton when there were no bike lanes. So accessibility, we need showers at workplaces. We need gym class, across the entire spectrum of high school. Now you can opt out in Ontario after grade 9. A little bit about that, but, we're getting a little bit off track, but, things that I'm very passionate about. I think that if we use genomics in the wrong way to slot kids or even, adults into certain exercise programs versus letting them explore and enjoy, because I think everyone's an athlete. You just got to find what you enjoy.
For sure.
Training, that's the negative connotation we get with exercise.
Yeah. And part of the fun of that is the discovery process, right? I mean, with respect to the athletic typing per se, I've never really been a fan of that. And actually, I only talked about the injury predisposition. I actually did the analysis on the different exercise response genes. And you would see world-class 800-meter runners with the sprint gene. And actually then in that scenario, it was like, hey, did you know that you could add this little bit of information to your race strategy? Like you could be a sit and wait, kick at the end type of athlete because you've got this great engine that you've built, not because necessarily you had the genetic predisposition for it. I mean, you leverage the environment to overcome your genetics. You're doing the sport that you love. But now, if you add a little bit of this plyometric training, a little bit of this weight training, a little bit of this speed training, your 200-meter kick could be like 22 seconds or 21 seconds and, 20 point maybe for 800-meter run. That's amazing. Now, don't over-index on it because, you still have the load of the physiological, VO2 max adaptation. You got to keep that going. And so it's like this minimum effective dose game, but that's what you're playing at the tip of the spear, which, I would argue you're playing a version of that later on in life. Like, you had mentioned, it's like one of these things is like, well, don't get injured because, I mean, when I had a, knee surgery, a shoulder surgery, it's like, 2-3 weeks of inactivity is, it's just drastic in terms of how much muscle mass loss is seen in that period of time. And so,
Just stay following up on that. Not only muscle, mitochondria. So we
mitochondria, bone,
healthy men and women. Yeah, these are physiology students. We put in a mobilization splint on their leg for 2 weeks.
Oh,
within 48 hours, there was a 70% reduction in PGC1, the main master regulator of mitogenesis. At 2 weeks, enzyme activity and protein were down by 25%. So think about a 60 or 70-year-old who comes in for a hip or knee replacement, and they're out for 6 or 8 or 10 weeks. They're already coming into it with muscle atrophy, a slight decrease in the nerve innervation of their muscle, mitochondrial dysfunction to begin with. Then you throw 6 weeks of immobilization. So I think prehab, being active to begin with, is probably the best strategy. So you're coming into it with better muscle. But very active rehabilitation is just critical for older adults to overcome injuries, which we're all going to get. But, suck it up, sunshine, just get going and get moving. The inactivity further compound your aging process.
Yeah. I mean, certainly there's, first principles that are, you ignore at your own peril, right? So how do we get more people active? How do we get more people to stay active? I mean, for me, and this, again, my bias is what has attracted me to it is just a genuine curiosity of like, wow, this is how life works. And so just constantly learning more has led me to explore more of, what my body could do. And so, the child in me, that child curiosity is like, I want to pass that on to my own daughter. And it's like, hey, your body is worth knowing. And to your point, we don't want to misuse genetics, but I think in the realm of like the nutritional intervention, that's a different story compared to, well, here's your genetics of your physiology and anatomy and only do those things. But with respect to this population of vulnerable people to macular degeneration, which is me, by the way, I'm like, okay, well, I have an appointment with my eye doctor next week, and this is on my list of things to talk about. And so then I know I can look at my genetic profile and see if I have that vulnerability. So should I or shouldn't I? And so, but then the ophthalmologist is going to say, well, I can't prescribe you that because there might be this thing. And it's like, well, it actually might be good for me. Like, yeah, well, I don't want to experiment. You want to do that on your own, go ahead. But then it could be like, but wait, here's the DNA, right? And so like, how do we get to that future where we have responsible access and sharing the DNA? Because like for me, for example, I have access to my whole genome. I've loaded it into my own large language model. And so when I go in and I get my surgery and the anesthesiologist comes out and is like, hey, do you have any drug allergies? My running joke is like, I don't know. I haven't tried them all. But now I'm like, actually, no, but show me the drug protocol. Like, what are we doing? And what's my outpatient? And give me everything. And then I can load it in. And it's like, oh, turns out Celebrax, I'm a negative responder to that. And I actually knew that, but I forgot about it that time when I had my labral tear corrected. I had a resting heart rate of like 160 and was burning up and had to go out for a walk like the day after my surgery because I was like, I can't handle this. But I thought it was something else. I didn't even think that's what it was. But it was like, okay, let's kick out Celebrex and we'll throw in Benadryl if you need it, right? So, and then the other one is, any of these like opioids, it's like, keep those away from me. So yeah, I again, like I know Canada's investing into understanding all of these diversities. And, my concern as, let's say, a recovering academic is that's great, but how do we go from basic research and understanding to improving lives? And I've had lengthy conversations about this with people like Chris McMaster, who you probably know. I think he's the chair of genome CIHR, Canadian Institute of Health Research. He's at Dalhousie University. Yeah, and he does work in the rare disease space. You guys would have a lot of great things to talk about. But, it's his position that it's like, yeah, okay, well, we could have every newborn sequenced like today, but how do you put that into clinical care when doctors are already overloaded and they're not trained in it? And okay, what's the healthy balance between technology, high tech versus like the high touch and the responsible stewardship of that data? I mean, I ultimately see it as like, at least this is how it is in my family, is like, this is what we talk about around the table, right? Like my nutrient requirements are different than my daughter's, are different than my wife's. And it's like you adjust the rudder a little bit today. That makes a big difference 10 years from now. And it makes a big difference if you're an athlete 10 minutes from now. So yeah, I mean, I am this is a question that I don't have the answer to. I'm just kind of putting it out there because I've seen all of these, advancements or research collaborations starting to happen. And I'm seeing, like, hey, Canada could be, this hub for innovation. They have all these, founder populations like in Newfoundland and Quebec and these new immigrant populations and actually, potentially very effective, not even clinical interventions, like lifestyle interventions that can be optimized genetically today if we just had the right way of communicating it. So anyway,
it's a huge question. It gets to newborn screening, and talking about this at Newborn Screening Ontario, we're very aware that we can sequence the genome in everybody. But the big challenge is we don't have the genetic counselors or the doctors to handle. I'm part of the Newborn Screening Ontario. We're the regional center for screening for spinal muscular atrophy. So 95% of the people who have this will have 2 deletions, easy to screen for, so we can rapidly screen it in the population. And we now have an intervention. So the intervention essentially takes a kid who's going to die at 2 years of age with SMA type 1 to all of my kids are walking now with the new gene therapy. It's just absolutely mind-blowing. However, that's one of 22,000 genes. So when you start thinking about the other, if you can't do something about it, what is the value of knowing? And so that's a bit of a challenge, right? Because, some people may not want to know. There are a lot of people who just say, look, I don't care what my genes are showing. I just want to go through life and just experiment and not have this, this sort of Damocles over my head that I'm going to get macular degeneration. And so do you then grant that to someone the access when they're 16 and they can sign consent? So many things that come into it. But certainly from a newborn screening perspective, unless you are going to change the outcome, then it's not put on newborn screening. And it has to be very carefully titrated in so that we don't overwhelm people. Because, the average family doctor, even, your average geneticist who deals with this stuff, if you've got, some polymorphism in the gene, is it pathogenic or not? How are you going to prove that? And we just don't have, we have large databases out there already that we can comb for new variants, but even those are sometimes really problematic and a huge amount of work. But there are instances where it makes sense. But certainly from a nutritional exercise perspective, my feeling as, pediatrician and an adult medicine specialist is wait till you're of the age of consent. Let kids be kids, let them play, let them make mistakes, let them do all these things. It's not going to harm them for the rest of their life. When they're 16, I think we can start thinking about, titrating in some more information to these individuals at a time where, they can still make some changes if they so desire, but it's informed consent is
Yeah, that makes a ton of sense. And in that scenario, do you imagine, given how far your research has come, do you imagine it like it? Well, you probably already have like some kind of omics models, whether there's, different gene markers that you look at collectively, different methylation profiles, like glycosylation profiles. Like you probably have a sense of what those models are already. Is that fair to say?
Yeah, there's 2 different parts to this. One is obviously, diagnosis of rare genetic disease, which is one aspect of my life. And then, some of these other changes that occur that are more lifestyle associated. So changes in diet, how does that affect methylation? For example, one really horrible McDonald's meal can alter methylation overnight of your DNA and change how it's expressed. And getting a better understanding of the entire omics profile from your microbiome, your metabolome, your glycome, your proteome, and your genome and how those all interact is going to be a massive. And AI is going to help us, but it's going to be such an interesting and exciting area as we move forward. To a large extent too, I think if these can be used from a motivational perspective. So let's say, for example, we know that top sport athletes have this, microbiome or this metabolome. And if you're sedentary, you have this. Can you then have a score that gives you a health span score? We're working on something similar called the Body Composition Index, where we're trying to find the appropriate ratio between fat and muscle, which most people want more muscle, less fat, and coming up with the thing we call the Body Composition Index, which relates to knee extension strength, which relates to fall risk, which relates to VO2 max, which predicts health span and lifespan. And so that's one of the areas we're moving towards, is coming up with this body composition index. But I would love to have a multi-omics index, not just one or the other, because there's pros and cons to all of them. And I think AI could help us come up with the optimization across a variety of omics profiles to say this is a healthier omics profile. And then what one could do is try a nutritional intervention in that individual, check and see. And I think that's the important thing too, is to get towards personalized medicine with these, where you could try a certain exercise program with higher protein or a different type of protein and see, does it favorably enhance your methylation profile? And part of the advantage, I think, is we're probably going to see changes in some of these profiles, obviously not the genomics, but we'd see changes, let's say in glycomics or metabolomics or microbiome, which is crazy. Like when we still have to analyze this, but with TRIM7, probably the most consistent thing within days is you can feel your guts change. And constipated to become more regular. I've got IBS totally gone when I'm on it. So that changes very rapidly. So you don't have to wait 3 months to see the outcome. Check and see, is it working in a favorable way? So I can see lots of really exciting opportunities. There's always the dark side, but there's so many benefits. It just has to be titrated carefully and appropriately to individuals.
Yeah, 100%. I mean, I did when I did my postdoc in Cornell with Ruth Lay, who is Jeffrey Gordon's understudy, who was the pioneer of gut microbiome metagenomics. We did the first case study of how the infant gut is colonized. And it was a hypothesis outcome study, right? So it was observational. It was just basically, 3 years of tracking the infant gut microbiome. And then when you look at it in reverse, you're like, wow, here are all of these environmental factors, changes in nutrition, introduction of antibiotics because of ear infection, changing out breast milk to cow's milk to formula. And it's just like boom, 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 boom. And you could see, the hypotheses were, and then this was done in collaboration with the Human Microbiome Project, which is an NIH funded initiative, some great labs. You got a picture of what a healthy microbiome looked like. And it wasn't necessarily specific species, maybe it was more like different phyla. And really, if you go back to the top, the main principle, first principles is really like, what's the diversity? And then, well, how do you define diversity? And then you might say something like, well, what's the resilience or what's the recolonization capability? How quickly can you do that? And, how far gone is too far gone? Like a C. diff is like, well, you can't recover that. That's like, those are, healthy donor, gut, transplants. Yeah. But so it's about, it's like, to your point though, with the methylation, it's like, well, it could change overnight. So if you happen to catch a bad one or a good one, so how is that metric even, and how is that informing the situation? And, but all that being said, I look at, okay, there's Henry Ford's Model T with basically, I doubt he even had a gas gauge, and then you've got Tesla, which is like, I can like upload from the cloud based on, the new research that we're doing. But by the way, Tesla, as I understand it, is not really a car company. It's a robot company. And there's all this data that they're collecting. And so there's that aspect of it. Like, how much of your data do you want to collect and share? And well, if you're an athlete, it's like, I've worked with some, top tip of the spear athletes that they want to know. Actually, they don't want to know anything. They want their coaches to know everything and make the decision. And that's something that they've agreed to because they want to be like Tom Brady and have their career be as long as possible. And by the way, that's not a longevity decision. That's a performance longevity decision, which is different than a health span. So there's all those interesting questions like, well, what are you actually trying to do? But at the end of the day, one of the things that I've seen is like great, brilliant scientists, researchers, medical practitioners such as yourselves. You have a lot of great proof, intuition and proof of, metrics that matter. And then, so it's like, well, how do we make that, speed of market responsible and, not the TikTok influencer dominated. So definitely a conversation for another day. But, before we wrap up here, I wanted to, check in those top 3 questions, right? So if this was our last podcast, is what would we want to say to people here? What would you want to say to people? And who should the message reach? Who needs to hear this? And then of course, the third question is, who might you recommend as my next guest?
Yeah, I think I'm kind of split between the first one. One is all kids are athletes. Give them a diversity of sports and let them pick what they enjoy. And the second, which is equally important, is on the flip side of that for older adults, and that is it's never too late to start. Always get benefits from doing physical activity. So that would definitely be the answer to the first question. I'm sorry I had to split that into two, but
that's okay. No, that's okay.
Yeah. Yeah, and then in terms of who would be the person to chat with, yeah, it's a tough one. I've thought back and forth many times. I think certainly I think my first postdoc, Stu Phillips, would be an interesting person. A lot of careful, thoughtful information on protein requirements. He'd definitely be an interesting person to have on the view as well. And sorry, the third question.
You answered them both. What was it? Who needs to hear it? You answered. I got a twofer with that one. So
right.
No, we're clear. Okay, well, great. I'll definitely extend the invitation for your recommendation, and we'll look to invite him on the show. But I can tell, Mark, we are set to have many conversations going forward, but I wanted to pause here and while this is the end of this show, I still certainly wanted to thank you for everything that you're doing, that you've already done, and that you will do, and very much looking forward to our next conversation.
Thanks so much. Appreciate it.
All right, we've just journeyed through the science of vitality, from the powerhouse of the mitochondria to the frontier of translational medicine. Dr. Tarnopolsky has painted a vivid picture of a future where aging is not a passive decline, but an active, negotiable process. The vision he has laid before us of a world where lifestyle interventions are prescribed with the same precision as pharmaceuticals is not a distant dream. It's a reality taking shape in labs and clinics. The responsibility now shifts to us. Knowledge has been shared, the path illuminated. It is up to us to walk, to advocate for it, and to build upon this foundation. The future of health is not something to wait for, it is something to create. And the work begins now.